Imagine a powerful editing desk where every change to your project's manuscript can be meticulously reviewed and refined before final production. This is precisely what the Git staging area offers, a vital yet frequently overlooked feature or step in the Git workflow that functions like a director's cut in filmmaking, allowing the developers to organize and perfect the changes with intention before they become part of the project history. Today's session, Staging Area, Preparing Changes for Commit, builds upon our previous two discussions on the basic concepts of Git. Namely, the first one it was repositories, the foundation of Git, and the second one, the commits capturing the project history. We will explore how the staging area or index is not merely a stop along the path, but a formidable tool in the Git workflow. This critical component enables developers to exercise precise control over which changes make it into the final commit, ensuring that each one of these commits are clear, purposeful, and beneficial to the project's progression. For DevOps engineers or professionals, mastering staging area is very critical or essential. It ensures that every commit not only adds value but also maintains the historical clarity and technical integrity of your project. Let's dive deeper into how to leverage this powerful yet underappreciated feature to the fullest potential. So, what is the staging area? The staging area or index in Git is a concept that might seem elusive at first, but it's where much of the magic of the version control really happens. It serves as an intermediate area, a unique space within the Git environment where changes from the working directory are gathered and meticulously organized before they are committed to the repository. Think of the staging area as a buffer zone. It exists between the working directory, where you actively modify files, and the repository, which is the final record of all the project history. The buffer zone is crucial because it allows you to control exactly which changes you commit. Instead of committing all the changes you have made since the last commit indiscriminately, the staging area allows you to pick and choose what changes you want to commit and keep it in the history. You can decide to include only certain parts of your work in a commit while leaving others for later consideration. This selective staging capability provides a significant advantage. It allows for precise, clean commits that are easy to understand and manage. Each commit can then be tailored to include only related changes, making the project's history more coherent and easier to navigate. For example, you might have made multiple changes, multiple types of changes in your file, some bug fixes and some feature additions and some enhancements, some memory optimizations. With the staging area, you can choose to stage and commit all the bug fixes in one commit and all the feature additions in another commit, keeping them neatly organized. By leveraging the power of staging area, you enhance your control over the development process, ensuring that each commit accurately reflects a specific set of changes and contributes meaningfully to the evolution of the project. This keeps your project history clean and very well documented. Why should you use staging area in your projects? The staging area is a fundamental aspect of Git that offers several key benefits, which enhances both the quality as well as the manageability of your commits. Let's explore why utilizing the staging area is crucial for effective version control management in your project. The first use case or the benefit is that you can review your changes before you commit. The staging area provides a crucial checkpoint before you finalize your commits, all your changes before you commit. Here you have the opportunity to review all the changes you have made since your last commit. This review process ensures that only the intended modifications for the files or even the parts of the files are included when you commit to the repository. It's like a final quality check or a checklist or a checkpoint that prevents accidental commits of incomplete or erroneous changes, or ensuring that which ensures that every commit is intentional and accurate. The second one is, you can create logical commits. One of the best practices in version control is creating commits that are logically organized. The staging area facilitates this best practice by allowing you to selectively stage changes. This means you can group related modifications together into a single commit, as we just mentioned before, making each commit a coherent unit, an atomic unit that accomplishes the specific purposes. Logical commits are not only easier to understand and review, but also simplify your for future maintenance costs, such as bug tracking and reverting changes if necessary. The next benefit is you can organize your work. In any significant, non-trivial development project, organizing your work is key to manage complexity. The staging area helps you to sort and group changes that pertain to a specific features or a bug fixes. By staging related changes together, you can manage a larger task more effectively, ensuring that each commit moves a specific aspect of the project or a feature of the project forward in a meaningful way. Next benefit is that you can avoid an unnecessary commits or accidental commits. Finally, staging area acts as a filter to prevent clutter in your project history by allowing you to select precisely what changes to commit in a specific commit. As a group, it ensures that your repository does not be bogged down with unnecessary commits. This selectivity is especially valuable in a collaborative environment where clarity and precision in the commit history are crucial for team dynamics and workflow efficiency. Let's break down some of the key concepts associated with the Git staging area, helping you to understand how to effectively manage changes between your working directory and your commits. The first step in leveraging the staging area is that you have to add your changes to the staging area itself. When you modify your files in your working directory, those changes remain outside of the version control system until you take an explicit action. To include these modifications in your next commit, you must use the git add command. This explicit action is crucial because it gives you control over what changes can make into the next commit, allowing you for selective inclusion based on your decision, which is based on what's appropriate for your project goals at this particular moment. Next critical concept is staged versus unstaged changes. This distinction is key in managing your workflow, which ensures that only the desired changes are committed to your repository. Understanding the difference between these staged and unstaged changes is fundamental. Unstaged changes are those modifications that have been already made in the working directory, but not yet have been committed to the staging area. This could be new files, modifications, or deletions that are pending a decision on whether they needed to commit should be committed in the next go. On the other hand, the stage changes are those that have been already added to the staging area and ready to be committed in the next go. This distinction between stage changes and unstaged changes is key in managing your workflow and ensuring that only the desired changes are committed to your repository. One of the more advanced and incredibly useful features of Git is partial staging. Git allows you to stage not only the entire files, but also a specific part of the file. For example, if you have made say several changes to a file, but only you want to commit only a specific set of lines of the changes or a specific method in a big class, or a big paragraph of a file, Git allows you to add only those lines or sections into the staging area. This can be done using the git add -p command. -p stands for patch mode, offering an interactive way to review and select individual changes to include in your next commit. These concepts about the staging area form the core of effective change management in Git. By mastering how to add, differentiate, and selectively stage your changes, you can fully take advantage of the staging area to make your commits more precise and meaningful. This not only improves the quality of your overall project history, but also enhances the collaboration and the project management in the team environments. Before we go to the specific commands related to staging area, let's look at a few practical examples from the Medibooks projects to illustrate how the staging area can be strategically used to manage changes within a repository effectively. These examples highlight the benefits of selective and organized staging in maintaining a clear and clean and manageable project history. The first example is staging the UI changes. Consider the example of Dana, who is tasked with enhancing the user interface while also Consider the example of Dana, who is tasked with enhancing the user interface while also addressing bug fixes in the Medibook's front-end repository. Dana chooses to stage the UI improvements separately from the bug fixes. By doing this, she ensures that each commit is focused and addressed only one concern at a time. This method makes the commit history cleaner and more understandable. Whenever there is a need to revert the UI changes without disturbing the bug fixes, this separation makes it possible without any complications. Next, let's look at Bob, who is developing a new feature for the payment module. Bob makes changes to both the API business logic and the configuration files. However, to keep his commits clean and focused, he desires to stage only the API logic changes for now. The configuration changes remain unstaged until they are ready for a separate commit. This approach allows Bob to make his commit exclusively about API updates, simplifying code review and tracking the progress of the feature development more clearly. Lastly, we have Alice, who has been working on several enhancements to the appointment reminder system. Instead of bundling all these changes into one large unwieldy commit, Alice uses the staging area to carefully organize her work. She first stages and commits the updates to the reminder logic, ensuring that this business logic unit is captured in one commit. Following this, she stages and commits the changes to the notification template separately. This methodological use of staging area helps in segmenting large set of changes into manageable, understandable parts, facilitating easier maintenance and review. Each of these examples demonstrates how the staging area can be used not just as a buffer between the working directory and your repository, but as a powerful tool for organizing, reviewing, and committing changes in a way that enhances project management and collaboration between your team members. Finally, let's explore some of the key commands that you will use to interact with the Git staging area. These commands are fundamental tools that enable you to precisely control how and what changes are prepared for commits. Understanding and utilizing these commands will significantly increase your efficiency and precision in version control system and version control management. The most basic command to interact with the staging area is git add and give a space a file. Git add a specific file. This command adds a specific file to the staging area, preparing for it to inclusion in your next commit. If you have made several changes but you only want to commit one specific file, you can do so by specifying its path in the git add command. You can give a nested path, you can give a specific path to relative to your current working directory. This is particularly useful when your changes are widespread and you want only some of the files are ready to be committed. Now you want to add all your changes into the version control. So this command git add dot which indicates the current directory and all its children, all its child directories. This command stages all the changes in your current directory and subdirectories, making everything you have modified so far between your previous commit and now are ready for a commit. So everything will go into the commit into your repository in the next commit. This is a quick way to move all your work to the staging area, but it requires caution to ensure you don't accidentally stage files that are not ready for commit. Okay, now often you need to check the status of the difference between, or what are the stage changes, staged files, and what are the unstaged files. So git status commands will allow you to have a clear overview of the current state of your working directory and the staging area. This command provides a clear overview of the current stage of your working directory and your staging area. It shows which files have changed that are staged for commit and which files have changes but that's not have been added to the staging area yet. So you can see the files between files which are staged as well as the unstaged files in one shot. And this command is crucial for ensuring that your next commit contains exactly what you intend. Now, for the partial staging, for a more granular control over your commits, you can use the git add -p, the specific file name. The -p command option allows you to interactively select changes in a file you want to stage. This means you can review each change and decide whether to include it in the staging area, offering precise control when you want to commit to only specific parts of the file. These commands form the backbone of your interactions with the staging area. This empowers you to manage your changes with high precision. Mastering this will help you to ensure that your commits are always deliberate and your project history remains clean and descriptive. As we wrap up today's session on the staging area and its key components, I hope you have gained valuable insights into effective management and organizing your changes before committing them into the repository. The staging area is a very powerful feature in Git. When used wisely, you can greatly enhance the clarity and the precision of your project's history. It will keep your project history very clean and very descriptive. Looking ahead, our next session will delve into Git push, the final step in the standard Git workflow. Pushing is what allows you to share your commits with others by uploading your local repository changes to a remote repository, whether it is a public repository like GitHub, Bitbucket, or anything, or even your organization-wide local or private repository. This step is crucial for collaborative development in your organization, as it enables you to synchronize your work with your teammates and contribute to the broader projects. Join me next time as we explore how to effectively use Git push to make your contributions count, ensuring that your work is safely integrated and accessible in the shared project environment. We'll cover everything from basic pushing techniques to handling conflicts and understanding the nuances of remote branches. Thank you for listening so far, and I'll see you in the next session.